Hello, this is Matt Dean with A+ College Ready, and today we're going to do some reaction prediction practice problems. We're going to start off with magnesium plus oxygen. Here we have two elements, so we're adding them together. This is going to be a synthesis reaction. So we have magnesium, Mg, plus oxygen. Remember that oxygen in its pure form is diatomic oxygen gas, O2. Those add together. Remember that Mg is a +2 ion or 2+ ion, and oxygen is a 2- ion. So the compound formed between the two of these is going to be MgO. We need to go back and balance by putting a 2 right here and a 2 right here. And again, that's a synthesis reaction. The second one is aluminum plus hydrochloric acid. So here you have a metal plus a compound of some type. So this is going to be probably a single replacement reaction. So let's write out aluminum plus hydrochloric acid, HCl. You need to check your activity series here, and you need to make sure that the metal, aluminum in this case, is above hydrogen in the activity series, and it is. And that means that the metal will replace all hydrogen from the acid. So we're going to get hydrogen gas being expelled as H2, and we're going to get a compound between aluminum and chloride. Well, aluminum is a 3+ ion, chloride's a -1 ion, so aluminum chloride is AlCl3. We need to balance this equation, and to balance, we need to put a 2 in front of the aluminum and a 2 in front of the aluminum chloride. We're going to need to put a 6 in front of hydrochloric acid and a 3 in front of H2. Check to make sure that you have the same number of atoms of each kind on both sides. I think you do. And again, this is a single replacement reaction. Alright, the next one we're starting with sodium chlorate, which is NaClO3. We're heating it, which we might slow with a delta or a delta H. Since we only have one compound, this has got to be a decomposition reaction. And the rule is that chlorates decompose into metallic chlorides plus oxygen gas. So we know we're going to get some O2. Well, the only metallic chloride we could get here would be sodium and chloride. Formula for sodium chloride is NaCl. We need to balance this by putting a 2 in front of here, a 2 in front of here, and a 3 in front of O2. So again, that's a decomposition reaction. It's a metallic chloride decomposing into, a metallic chlorate decomposing into a metallic chloride and oxygen gas. Next we have zinc chloride plus ammonium sulfate. So we have two salts. Here's the zinc chloride and ammonium sulfate. So when you have two salts like this, you're probably going to get a double replacement reaction. So we're going to switch zinc over with sulfate. Zinc is a 2+ ion, sulfate's a -2 ion. So that's zinc sulfate. And then we're going to get ammonium ion with chloride. Ammonium is 1+, chloride is 1-, so NH4Cl. We need to balance by putting a 2 here, and that should take care of it. We need to check our solubility rules. And when you look at your solubility rules, you're going to find the rule about sulfates. That rule says that sulfates are soluble except for those of group 2, lead, silver, and mercury. Which means that zinc sulfate is going to be soluble, so it's aqueous. Well, ammonium chloride, one of our solubility rules says that all ammonium compounds are soluble. Another one says that the chlorides are also soluble except for with silver, mercury, and lead. So this is also aqueous. Since both of our compounds are aqueous, we're going to say on this particular reaction that there is no reaction because we started with a bunch of ions over here on the reactant side floating around in water, we ended up with exactly the same ions floating around in water. So there was no net change, no reaction. So now we're going to move on to the next one, calcium carbonate heated. This is another example of a decomposition reaction. And the rule is that metallic carbonates, when heated, will decompose into metal oxides plus CO2. So the metal oxide has to be calcium. Calcium's 2 plus, oxide is 2 minus, so CaO. And then plus carbon dioxide. We need to balance this equation. Turns out it already is balanced. So it's going to be CaCO3. Maybe put a little delta there to show the heat. Breaks down to CaO plus CO2. Decomposition reaction. All right, the next one is potassium plus water. So here's potassium plus water. This is going to be a single replacement reaction. Now remember that only metals, sodium and up on the activity series will react with water, and they'll displace just one of the hydrogens, and they'll leave behind a hydroxide plus hydrogen gas. So we're going to get hydrogen gas, H2. We're going to get a metal hydroxide, so it has to be potassium hydroxide. Potassium is a 1 plus ion. Hydroxide is a 1 minus. So that's going to be KOH. And we need to balance by putting a 2 here and a 2 in front of the water. Also a 2 in front of the potassium. So that's a single replacement reaction, the reaction between a metal and water. Next we've got sodium hydroxide plus phosphoric acid. Well, sodium hydroxide is NaOH. Phosphoric acid is H3PO4. This is a double replacement reaction, or we might say it's a neutralization reaction. It's the reaction between an acid and a base. And we know that when we react acids and bases, we get a salt and water. So the H from the phosphate is going to end up replacing the hydrogen, or the sodium from the NaOH. So that's going to leave us with H2O, which we know is a liquid. And we're also going to get a salt, and that's going to be sodium and phosphate. Sodium is a 1 plus ion, phosphate's a 3 minus. So our formula for sodium phosphate is Na3PO4. All sodium compounds are soluble, which means this is an aqueous compound. That should say AQ there. It doesn't look very good. So we need to balance this equation, and it turns out it is balanced as written. So this is a double replacement or neutralization reaction. Next we have chlorine, which we know by itself is a diatomic gas, plus calcium fluoride. This looks like it might be a single replacement reaction. Remember that halogens can replace other halogens from a compound. But you've also got to remember that, sort of like with the metal activity series, halogens become more active as you go up the halogen column, which means fluorine is more active than chlorine. Only more active halogens can replace less active halogens. Chlorine is not more reactive than fluorine, therefore this is a no reaction. The next one is just the opposite kind of problem. So here we have fluorine, also a diatomic, plus calcium chloride. Single replacement reaction. Fluorine is more active than chlorine, so it replaces it. So we get chlorine gas plus calcium fluoride, CaF2. We need to check to make sure that it's balanced. It is balanced as written. So this is a single replacement reaction in which a more reactive halogen replaces a less reactive halogen from a compound. All right, next we have iron plus hydrochloric acid, a metal plus an acid. So we need to check to make sure that that metal, in this case iron, is above hydrogen on the activity series, and it is. So the metal is going to replace all the hydrogen. So we're going to get hydrogen gas, H2, plus FeCl2. Now remember that iron also has a +3 state, so we might also get some FeCl3, I'm going to write it like this though, and I'm going to balance it out with a 2 right here. And that's a single replacement reaction. Reaction between a metal and an acid. Next, we have silver nitrate plus potassium chloride. So we have two salts reacting together. Silver nitrate is AgNO3. Potassium chloride is KCl. So they double replace each other. So we're going to get potassium with nitrate. And we're going to get silver with chloride. Both of those are 1+ ions. We check our solubility rules. All potassium compounds pretty much are soluble. All nitrates are soluble, so that one's aqueous. And we see that most chlorides are soluble, but the ones with silver are not, which means that silver chloride is going to form a precipitate, a solid. So this reaction does happen. We need to make sure that it's balanced. It is balanced as written. So this is a double replacement reaction between two salts. Next we have magnesium plus copper sulfate. So this is a reaction between a metal and compound. Metals can more active metals can replace less active metals. So first of all, we check to make sure that magnesium is above copper on the activity series. Turns out it is. So the magnesium will replace the copper. We'll get pure copper metal. And we'll get magnesium sulfate. Magnesium is a 2+ ion. Sulfate's a 2- ion. So that is a single replacement reaction, balanced as written. Next we have copper plus water. So this is a metal plus water. Remember that only metals that are sodium and up on the activity series react with water. Copper is located well below sodium on the activity series, which means we get no reaction on this one. The next one is sodium oxide, which is Na2O, plus water. This is a metallic oxide plus water. And the rule is that produces a base, or a metallic hydroxide. Well, the metallic hydroxide has to be sodium hydroxide, since sodium is the only metal involved on the reactant side. Sodium is 1+ ion. Hydroxide is 1- ion. So that means sodium hydroxide is NaOH. We need to balance with a 2 in front of the sodium hydroxide. Next, we're looking at ammonium nitrate plus lithium hydroxide. So again, this is a reaction between two salts. Ammonium hydroxide, or ammonium nitrate rather, is NH4NO3. Lithium hydroxide is LiOH. These are going to double replace. So we're going to get lithium with nitrate. Lithium's a +1 ion. Nitrate's a 1- ion. All nitrates are soluble, so this is aqueous. And it looks like we would get NH4OH, ammonium hydroxide. But hopefully you guys remember that when it looks like you're going to make ammonium hydroxide, that compound is very unstable and very quickly breaks up into ammonia, which is a gas, plus water, which is a liquid. Need to balance this. It turns out it's balanced as written. So this is a double replacement reaction between two salts. The reaction does happen because we get both a gas and a liquid. Next we have potassium plus chlorine. Don't forget that chlorine is diatomic in its pure state. This has to be a synthesis reaction. Potassium's a 1+ ion, chloride's a -1 ion, so we get KCl. We're going to balance with a 2 and a 2. And again, that's a synthesis reaction. Next we have zinc plus copper 2 sulfate. So this is a metal plus a compound. Remember that more active metals replace less active metals from a compound. Zinc is located above copper on the activity series. So we get zinc sulfate plus pure copper. Check to make sure that it's balanced, and this reaction is balanced as written. Again, it's a single replacement reaction. Next we have dinitrogen pentoxide plus water. Now this is going to be a synthesis reaction. and the rule is that 9 metal oxides plus water yield an acid. And in this case, the only really acid that you can make that would balance is nitric acid. And you need to balance this thing by putting a 2 right here. And I think that'll take care of it. So that's a 9 metal oxide plus water yields an acid. Next we have sodium carbonate plus hydrochloric acid. Well, here's sodium carbonate plus HCl. This is going to be a double replacement reaction. So we're going to get sodium with chloride. That's an aqueous compound, if you check your solubility rules. And it looks like we should get H with carbonate, hydrogen carbonate. But that's carbonic acid. Remember, carbonic acid is very unstable and quickly breaks apart to yield water, a liquid, plus carbon dioxide, which is a gas. You need to balance it. To balance it, you put a 2 in front of the NaCl and a 2 in front of the HCl. So this is a double replacement reaction. It does occur because 2 of the products, one's a liquid, one's a gas. Here's another double replacement, ammonium chloride plus sodium hydroxide. Very similar to a problem we saw just a minute ago. It's a double replacement reaction. We're going to get NaCl, which is aqueous, plus, it looks like we ought to get ammonium hydroxide. Remember that that compound is unstable and breaks apart to yield ammonia, a gas, plus water, a liquid. Again, check to make sure that it's balanced, and this one is balanced as written. So that is a double replacement reaction between 2 salts. The reaction does occur because it creates a gas and a liquid. And that's it for our reaction prediction problems. Hope that helped.